Hello and welcome to this session. In this session, I'm going to talk about the introduction to MATLAB programming. So whenever you open the MATLAB programming, you will find a window, which is basically what we call a command window with this MATLAB script, which is double greater than sign. Whenever you type something here, like 2 plus 5, and press enter, MATLAB will reply with the answer, which is the answer to the expression you have written there. So basically, we call this the command window. Then we have in this side the section where you have the current folder, which shows the current folder and the items in the current folder. Then it's down here, the workspace, which shows the variables in the that are available for the current session. So I'm going to go directly into matrix, the introduction to MATLAB programming. So MATLAB is a mathematical and graphical user software with numerical, graphical, and programming capabilities. It includes an integrated development environment as well as both procedural and object-oriented programming constructs. It has built-in functions to perform many operations, and there are toolboxes that can be added to augment these functions. When the MATLAB software is started, a window opens, in which the main part is the command window. So this window will look like the one we have here. So with the MATLAB script here showing the what we call the command window here, the white space here, then the current folder showing the items in the current folder, and then the workspace, which should basically show the variables that are available for the current session. The double greater than sign here is the MATLAB prompt. So when you enter some command there and press enter, MATLAB will reply with the answer to the mathematical expression that you indicated there. So the command window, as I have said, will open with the MATLAB prompt, which is the double greater than sign. And if you type something like cosine 1.2, then MATLAB will reply with the answer is equals to 0.3624, which is the value of cosine of 1.2 radian. For example, you have here, you have cosine of 1.2. You learn this part and you get the answer. The answer is 0.3624, which is the cosine of 1.2 radians. If the angles are given in degrees, then we use the MATLAB function cos d. D means degrees. So you enter the angle in degrees. For example, cosine of 45 degrees should give the output as 0.7071. So when we run this section, we get the answer as 0.7071. We can also enter sine d 60. That will be sine of 60 degrees. When we run that, we get 0.8660, which is sine of 60 degrees. We can write something like cosine of W1 is equals to cosine of pi over 4, or W2 is sine of pi over 3. This is the angle in radians. Pi over 4 is equivalent to 45 degrees. Pi over 3 is 60 degrees. So this should give me cosine of 45 degrees as we have here, and sine of 60 degrees. So when I run that, I should get W1 sorry, when I run this one, I should get W1 is 0.7071, which is the same as cosine of 45, and W2 is sine of 60 degrees, 0.866. You can see the output here. Also, now the variables W1 and W2 are stored in the workspace here. W1 is 0.7071, W2 is 0.8660. Now, if you type 3 plus 4, MATLAB will reply with the answer is equals to 7, which is the sum, 3 plus 4. A log of 3 will output the logarithm to base e, while log 10, 3 will output a logarithm to base 10 of 3. So we have these two. If you run, log 3 will be the logarithm to base e, while log 10, 3 of 3 will be basically logarithm to base 10. Now we have variables in MATLAB. To store a value in a MATLAB session, a variable is used. To create a variable, we use what we call an assignment statement. The format of the assignment statement is as follows. Variable name, then the equals, then the expression. So the variable name is basically the name that you are going to assign to this variable. The equal sign here is known as the assignment operator, and the expression basically is the value that you are going to assign to this variable. So it is important to note that the variable is always to the left, followed by the equality symbol, the equal symbol. The equal symbol, which is known as the assignment operator, is used to assign values to a variable. For example, we can write my var is equals to 10. This should create a variable called my var, and we'll store a value 10 in it. So if I run this one, I should get my var equals 10. Also, in the workspace here, you will see my var with a value. The name of the variable is my var, and the value is 10. We have the workspaces. A statement such as z is equals to 5, as we have seen, we will create a variable that will be called z, and we'll store a value 5 in it, and saves it in a part of a computer memory that we are calling the workspace. A workspace basically is a collection of all variables and arrays that can be used by MATLAB when a particular command is executing. All commands executed in MATLAB in the command window share a common workspace. So they can all share variables. A list of variables and arrays in the current workspace can be generated with the whos command. So if we type, for example, these commands here, the command clear all should clear all the variables in the workspace. And then y1 is equals to 3.4, y2 is equals to 5, y3 is equals to 2. This should create a vector with the elements 2 and 3. y4 should create a vector with the elements 1 up to 5. So when I run this one, this will first clear all. We'll first clear all the variables in the workspace, and then each of the variables here will be created. So when I run the section, you'll see that, I don't know whether I'll run the section. When I run this section, all the variables that were in the workspace were created, and new variables are created. So the variables that were initially there were cleared, and now we have new variables in the workspace. So if we want to say the variables that are in the workspace, we can run the command whos. This should show all the variables that are in the workspace. So when we type whos, and run this section, I should see the output here, that we have the variable name, the size, the number of bytes used, and the class. So we have y1 is a 1 by 1. It is important to note that any variable in a MATLAB is treated to be a matrix. So when we have a scalar, it will be considered to be a 1 by 1 matrix. So y1 is a scalar, y2 is a scalar, so they are 1 by 1 matrices. y3 is 1 by 2, it has the elements 2 and 3, and y4 is a 1 by 5. It's a 1 by 5 matrix. So this command simply returns the list of all variables in the workspace. We have the command absolute value. So to find the absolute values, we use the function abs. So when I write abs 5, remember an absolute value of a number is simply obtained by squaring that number, then taking the positive square root. So for example, when we have minus 5, we square minus 5 to get 25. Then we take the square root of 25, which is plus or minus 5, but then we pick only the positive square root, which is positive 5. So when I run this, I should get positive 5. We have comments. Now, comments are basically some generic sentences, mostly written in a program, to explain what it does or what a piece of code is supposed to do. More specifically, they are written by a programmer to help him or her remember what a given line of code is supposed to do, or to explain to other programmers who may want to use the code in the future what the line of code is supposed to do. So comments have nothing to do with the logic of the code. They are completely ignored by the compiler and are therefore never reflected on the output. So they are basically used by the programmer to help him remember what the line of code is supposed to do. Because sometimes you may create a code, but then after a period of time, you may forget what that line of code was supposed to do. Or probably somebody else wants to use your program and they don't know what each line of code is supposed to do. So you put a comment in order to explain that. So in MATLAB, there are 3 types of comments. We have the single line comments, we have the block comments, and comments in a statement spanning multiple lines. We start with the single line comments. So single line comments are comments that require only one line. They are usually drafted to explain what a single line of code does, or what it is supposed to do, or what it's supposed to produce, so that it can help someone to refer to the source code. Normally, we use the percent operator for adding single line comments. This can be written in a separate line or appended to a code on the same line. The syntax is %, then you write your comment there. For example, you have disp, then disp is used to display. Below is the comment using the %. Then you type %, this is a comment. You see this line in green, MATLAB will not read this line. The moment it encounters the % sign, it will ignore anything else that comes after that. Anything else to the right will be ignored. So when I run this section, I should see only the text below is a comment using %, but nothing will be seen below that. So when I run that, I'll get below is the comment using %. Then we have the block comments. To make a block comment, we put the braces, the % brace, that is the starting of the block comment, and the a brace, the closing brace. You start with the percent, then with the opening brace, then you add with the percent followed by the closing brace. So that will mark the end of the block comment. So the syntax is you start with the percent followed by the opening brace. Then you write your comment. Anything that comes after that is a comment until where you have the percent followed by the closing brace. So for example, when I write something like that, below is a block comment using this. So there is the starting, the percent, followed by the opening brace. Then the comment, you can see this text is in green. So that will be considered to be a comment until after the percent followed by the closing brace. Anything that comes after this now, if there is anything else after this, now MATLAB will consider that to be the code, but whatever we have here is a comment. So when I run, you see this one is not does not appear in the output. Then we have the comments that span multiple lines. So commenting a part of a statement spanning multiple lines uses the ellipses. For example, we have x is equals to, MATLAB is a programming language that was invented by Cliff Muller. It is user-friendly. Now, when we start with these three dots and add the statement here with those three dots, it means that anything that appears in between here is considered to be a comment. So when I run this, it should output MATLAB is a programming language, then comma, it is user-friendly. So whatever the text in black will not appear. MATLAB is a programming language. It is user-friendly. So maybe I can schedule here. You can see MATLAB is a programming language. It is user-friendly. The statement that it was invented by Clever Muller does not appear. So to comment out lines of code in a script, we just press Control, then R, and to uncomment, we press Control T, or you can press Shift 5 to comment. Then after that, you just type, because when you press Shift 5, you just type the percent sign, which will be a commenting a line. Now we have matrices. As we have said, MATLAB stands for Matrix Laboratory, and anything you enter in MATLAB will consider to be a matrix. So the simplest matrix is a 1-by-1 matrix, which basically is a scalar. And this can be created by using the assignment operator. For example, we write A is equals to 3.3. This will create a variable called A with the value 3.3. This will be considered to be a 1-by-1 matrix. Now we can create another matrix, 1-by-1 matrix C. You see that when I type A here and run, I'll get the output. If I type C is equals to 5, then followed by a semicolon, this will suppress the output. So there will be no output here, but the variable will appear in the workspace. So there is no C in the workspace. But if I run this one, there will be a variable C created in the workspace with a value 5. You can say C is with a value 5, but there is no output here. So running this will not print C, basically in the console, but the variable C is created in the workspace. So we can therefore, because we have the variable C, we can perform mathematical operations with this variable. For example, we can type 2 times C. This should output the product of 2 and C, which is 2 times 5, a value of 10. So if we type B is equals to, then we start with the square bracket, 2 space 3, 4, then semicolon, 5 minus 2, 1. Then we close the square bracket. This will create a 2 by 3 matrix. So the semicolon here is used to add the row to mark the end of one row. So we have the elements 2, 3, 4. Then that is the end of the first row. Then the second row now begins with 5, minus 2, and 1. So when we run this one, this should output a 2 by 3 matrix. So I run this one. I get a 2 by 3 matrix. Maybe let me clear the output and run again. Run only this section. I get a 2 by 3 matrix. You can see the first row has the elements 2, 3, 4, and the second row is 5 minus 2, 1. So we create a 2 by 2 matrix. But if we run this second statement here, because of the second semicolon at the end here, there will be no output in the console here. So when I run this section, we serve the matrix B. Maybe I can call it F, just to see that it is different. We don't have F in the workspace here. So when I run, F will be created, but there is no output here because of the semicolon that suppresses the output. Now, we can access the elements of the matrix. For example, for the matrix B, we normally have the element 2 as, we call it B11, then B12, B13. Then the second row we start with now mentioning the row. So we talk about B21. So when we write B21, we mean the element in the second row, first column. So the next one will be in the second row, second column. So it will be B22, B23. So we can access those elements by typing B23, for example. This is the element in the second row, third column. So this will be display B23. When we run, we get a value is 1. We have the colon operator. The colon operator is used to generate a series of terms. So when we write A is equals to 1 colon 6, this generates a series of integers from 1 all the way up to 6. So with 1 as the first element and 6 as the last element. So the integers from 1, 2, 3, 4, 5, 6. So when we run this one, it will generate all those integers from 1, 2, 3, 4, 5, and 6. If we write B here is equals to 2 colon 4 colon, see that this is the full colon. Then 2 colon 4 colon 22. This will generate an arithmetic progression with the first term as 2 and the common difference as 4. So this will generate integers starting with 2. The next one is obtained by adding 4 to 2. The next one is now obtained by adding another 4. So the first element will be 2. Then the next one is 2 plus 4, which is 6. Then the next one will be 6 plus 4, which is 10. Then 10 plus 4, which is 14, and so on. The last one should be 22. The last one should be 22, a number that does not exceed 22. It may not necessarily be 22, but in this case it's 22 because we'll have 2, then 6, then 10, then 14, then 18, then plus 4 is 22. So when I learn that one, I'll get those numbers: 2, 6, 10, 14, 18, 22. Now, if I type sum of B, sum, then B, this should simply add the numbers, these numbers in B. That is 2 plus 6 plus 10 plus 14 plus 18 plus 22. This should give us the sum of that series. Sum of that series. While plot B will produce the product of those integers. So when I run that one, I should get the product: 2 times 6 times 10 times 14 times 18 times 22. Sometimes we may want to delete an element from a vector, such as B here. Remember, we have B has the elements 2, 6, 10, 14, 18, 22. To delete an element such as 10 here, if we want to delete the element 10, we notice that this element is in position 3. This is position 1, position 2, position 3. So we can access that by typing B3. If you type B3 here and learn that section, you should get that the answer is 10. So if you type that, then you put the square brackets and you don't put anything in between there, this will just delete the element 10 and output the vector with the elements 2, 6, 10, 2, 6, 14, 18, 22. So the element 10 is deleted. 2, 6, 14, 18, 22. We have the dimension of a matrix. This can be obtained by using the command size. Then you pass in the matrix name. For example, if you have the matrix B with the elements 2, 6, 7 in the first row, then 1, 9, 0 in the second row, then you type size B. This should output 2 by 3. 2, this should give us 2 by 3. The size here, if I run this one, I get B is a 2 by 3 matrix. 2 is the number of rows, 3 is the number of columns. So that indicates that B is a 2 by 3 matrix. If I run size B, 1, this will return the number of rows. In this case, the number of rows are 2. And if I run B, size B, 2, this should output the number of columns, in this case 3. Then the determinant of a matrix, of a square matrix. Normally, when we have a square matrix, if the number of rows and the number of columns are the same, we can find what we call the determinant of a matrix. For example, if we have a 2 by 2 matrix, 2, 4, 3, 9, if we have this matrix, 2, 4, 3, 9, the determinant is obtained by multiplying the elements of the principal diagonal, that is 2 times 9. Then we subtract the elements in the other diagonal. So we have 2 times 9, which is 18, minus 3 times 4, which is 12. So 18 minus 12 is 6. So that is the determinant of the matrix. In MATLAB, the determinant can be obtained using the function det, det, then you pass in the matrix name. So for example, in this case, the determinant of the matrix A will be equals to det, then we pass in the matrix A. This should give us the value of 6, as we have obtained there. The determinant of A is equals to 6. Then the inverse is obtained using the command or using the function inv. Then we pass in the matrix there. The inverse of this matrix is that. Now, consider another matrix here. Suppose we have this matrix. This matrix has the elements 2, 3, 5, 6 in the first row. The second row we have 4, 3, 2, 1. That's the second row. Then we have 0, 2, 1, and 8. That's the third row. If we run this, this should be a 4 by 3. That's a 4 by 3 matrix that has 4 columns and 3 rows. So the rows of this matrix are 1 by 4 matrices. Each row has 4 elements. So each row is a 1 by 4 matrix or row vectors. So they are row vectors with 4 elements. For columns are 3 by 1 matrices or column vectors with 3 elements. So to create a vector from this matrix, such as R2, whose elements are the elements of the second row, we can use the command R2 is equals to B2, comma, then the colon. The full colon will indicate, will say, this one is saying that we take the elements of the second row, an element from the second row, but here when we put in place of the column, we press the full colon, then we are saying that we pick all elements from the second row, all the elements in all columns. So when I run this, I would get the elements 4, 3, 2, 1. The elements of the second row. For the column, if we want to pick the elements from a certain column, such as column 3, 5 to 1, we write B, C3 is equals to B. Then normally to access the elements, we write the row, comma, column, where the element is located. For example, when I write 2, 3, I mean the element in the second row, the third column. So I'll count this, the first row, second, then column 1, column 2, column 3. I would expect the element 2 there. So when I run, I should get C3 is equals to 2. But now if I want to pick the elements from all rows, I'll just put here the full colon, indicating that I consider the elements in all rows, but in the third column. So when I run, I should get the elements 5 to 1. Now replacing or deleting some elements of a matrix. So given a matrix such as B, we have there, such as this matrix B, if we want to replace a certain element, such as the element B31, which has a value 0. If you look at B31, this one has a value 0. We may want to replace that with an element such as 7, a number such as 7. So we type B3, 1. This will access the element B31, and then we type is equals to 7. So that should replace the element B31 with the value 7. So we get a matrix now with the element 7. So to replace the entire first column, for example, with the elements, if you look at the first column, it has the elements 2, 4, 7. Suppose we want to replace this with minus 2, 5, 9. We type B in brackets. See that we are using the round brackets here. Then we put a colon, meaning that we want to access the elements in all rows. Then comma 1, meaning that we want the element in the first column. Then we type square brackets, minus 2, semicolon, 5, semicolon, 9. So this should generate, the colon here marks the head of a row. So this should generate a 1 by a 3 by 1 rather. A 3 by 1 vector. So it will just replace the first row, the first column, sorry. So when I run, the first column is replaced. You can see now the elements are minus 2, 5, and 9. 2, 4, and 7 have been replaced. If I want to delete that column, I write the same as I had written here, but now instead of putting the values, I leave it blank. So that should just delete that column, leaving the matrix B being a 3 by 3 matrix. Now, if I want to add a row down here, you see now this being a 3 by 3, there are 3 columns. So each row has 3 elements. So if I want to add one row down there, I will type B4. This is the 4th row, comma, then full colon, meaning that I want to access all the elements in that row. Then I type 1, minus 1, 6. This will add a row, a 4th row with the elements 1, minus 1, and 6. So when I run, I get a 4 by 3 matrix. We have calculations element by element using the dot operator. So the dot operator is used to perform element by element operations on vectors. For example, suppose we have the vector x, which is 2, 4, 10. This will have the elements, 3 elements, 2, 6, and 10. Then 3 to 7 will give us 3, then 5, then 7. So when I run this one, I should get those x is 2, 6, 10, then 3, 5, 2. So this creates 2 vectors. To multiply the elements of x by the corresponding element of z and store the result in the variable called n, I'll type n is equals to x dot star z. The dot here, we call this, normally the multiplication, we do it by using the star. When you use the star, this one is used to multiply. So for example, when you write 3, 4, then you put a star, 5, this should give us 4 times, the value of 4 times 5, which is 20. But now when we are dealing with vectors, we cannot just multiply these vectors like that, x and z. If we do that, we'll get an error because this one is a 1 by 3. You cannot multiply a 1 by 3 with another 1 by 3 vector. But suppose we want to multiply the corresponding elements, 2 times 3, 6 times 5, 10 times 7. We use what we call the element by element operation. This one is achieved by using a dot. So x dot times z. This should give us that output. 6, 30, and 70. That is 2 times 3, 6 times 5, 10 times 7. So similarly, the square, if we want to square each element of the vector x, we write m is equals to x dot. The caret is used to obtain the powers. So when we use the symbol caret 2, that means we are getting the square power 2. But we use the dot, meaning that we want to perform element by element operations. So when I run this one, I should get the square of each element of x. Remember, x was 2, 6, 10. So the square of those will be 4, 36, and 100. Then the transpose of a matrix. The transpose, if A is an m by n matrix, then the transpose, which is usually denoted by AT, is usually an n by m matrix. This one is obtained by changing the rows into columns or columns into rows. In matrices, in MATLAB rather, this one is achieved by using the prime operator, or this dash, this single quote. So if A is this one, this matrix, then the transpose will be that. It's obtained by changing the rows into columns. We have the relational and logical operators. The relational and logical operators are a fundamental tool for constructing conditions and making decisions within a program. These operators play a crucial role in controlling the flow of execution by evaluating the relationship between variables and determining the truth value of logical expressions. So we start by looking at the relational operators. Relational operators are used to compare values and express the relationship between them. They return a logical value, which is either true. In MATLAB, this will be represented by 1, or false, which is 0, based on the comparison of the results. Now, these operators are essential for building conditional statements that guide the program's behavior. We have the equals sign, which checks whether two values are equal. So, for example, if we write A is equals to 5, B is equals to 6, then we type A equals B, this will check whether A has the same value of B. If A has the same value as B, it will output a value 1. If not, then it will output a value 0, meaning that this one is a false statement. So in this case, A is 5, B is 6. So A is not equals to B. And so the output is logical 0, meaning that A is not equals to B. But if we had put 5 here, if B was set as 5, and we run again, we should get an output of 1, meaning that A is equals to B. But any other value different from 5 will give an output of 0, meaning that the value of A is not equals to that of B. Then not equals to, we have this one, which determines if two values are not equal. So if we type this, A not equals to B, and learn, this will check whether the value of A and B are equal. If they are equal, the statement will be false. If they are not equal, the statement will be true, because this one says that A is not equals to B. So the statement will be true if A is not equals to B, and false if A is equals to B. Remember, A is 5, B is 6, so they are not equal. So this should output a value 1, which means that A is not equals to B. It's a true statement. We have the greater than, which basically uses greater than sign. This one checks whether A is equals to B. So that one is a false statement, because we know A is 5 and B is 6. So A is not greater than B. A less than B checks whether A is less than B. So this will be a true statement in this particular example. Then we have the greater than or equals to. So we write greater than or equals to. this should give us a false statement. Less than or equals to, this is a true statement in this example. Then we have the logical operators. So logical operators, on the other hand, are used to combine or modify logical values. They are pivotal in creating complex conditions by connecting simpler conditions. These operators are crucial for constructing decision-making structures within MATLAB. We have the logical AND. So we use the ampersand operator. So this returns true if both conditions are true. Otherwise, it will be a false. It should include a false. So for example, if we write A, B, X, Y, deal 5, 7, 9, 2, this will assign A a value of 5, B a value of 7, X is equals to 9, and Y is 2. So this should output that A is 5, B is 7, X is 9, Y is 2. So we want to learn the statement. So the logical AND uses the double ampersand operator. A is greater than B and X is greater than Y. A is greater than B and X is greater than Y. You notice that A is 5, B is 7, so A is not greater than B. X is 9, Y is 2. So X is actually greater than 9, but A is not greater than B. So although the second part here of the statement is true, but this one says that A is greater than B and X is greater than Y, which is wrong. It's a false statement because A is not greater than B. This one simply indicates that both of these statements are true, but that is not true. One is false. So that should output as 0. The vertical line used for the logical OR. This returns a value 1, a true value, provided that one statement is true. At least one of the statement is true. So if we replace the AND here with the OR, so this statement should read like either A is greater than B or X is greater than Y. Now, because one of the statement is true, then this should output a logical 1. The logical negation, this reverses the logical value of the condition. So if we put the logical negation here and learn the first statement here, which was giving us a logical 0, now it should output a value 1. It should now output a value 1 because that's a negation of the logic. Now, the uses of logical and relational operators. We have the conditional and decision making. Relational operators are indispensable in constructing conditions for decision making structures, such as the if statement, switch statements, and the loops. They allow the program to execute different code blocks based on the evaluation of certain conditions. Then we have the logical combinations. Logical operators enable the creation of more complex conditions by combining simpler ones. This is particularly useful when dealing with multiple criteria that needs to be satisfied for certain action to be taken. So understanding and mastering these operators are fundamental skills for any programmer, as they provide the foundation for creating flexible and responsive algorithms that can adapt to different scenarios. We have the Boolean functions. Boolean functions are an integral part of logical reasoning and decision-making processes. These functions encapsulate logical conditions and return Boolean values, which is true, value 1 for true and 0 for false, based on the evaluation of these conditions. So Boolean functions play a pivotal role in enhancing the code clarity, promoting modularity, and facilitating efficient logical operations within a program. So Boolean functions will return a value 1, which is true, and 0 for false, the other Boolean functions that return the true or false may be void is empty, is finite, is none. None means not a number, is numeric, is real, is prime, is char. Char means the character. For example, suppose we create a vector W with elements, these elements. Let me just learn. I and F means infinity, NAN means not a number. So when I run, I get this vector with this set of elements. They are those elements. There should be 12 of them. Then we type I is finite, W. Then we pass in W. This should check whether each of these characters is finite. So this should output a value 1 whenever the element of W is finite, and 0 whenever the element of W is not finite. Like this one is not finite, so there should be a 0 here, and a 0 where there is the 0 where there is the element. You say this one is none, and that one is not a number, so that is not finite. Then the last one is also infinity, is not finite. So when I run this one, I should expect to get 0 at those positions and 1 elsewhere. You can see 0 and 0 here. Everything else is 1. So if we have something like A is equals to high, that's a string. B is equals to 300, that is a numeric. So when I run, I get that. So I type A1 is equals to is numeric A. So A is not a numeric, it's a string. So that should output 0, which means that this is a false statement. But if I type A, if I put the negation of that, A2 is the negation of that, that should now output a value 1, the logical one. Also, if I type A is char, that's a character, that will give me a true statement, value 1. Also, I can learn this. I say B1 is numeric, B is numeric, so that is a true statement. Is char will show 0. So next we look at the symbolic mathematics in MATLAB. I think I'll look at that in the next video. So this one I'm going to edit at that point. Then in the next one, I'll start with the symbolic mathematics in MATLAB programming.